monomials.
Objective: to find the powers of monomials. Whee! So let's talk about the more rules of exponents. Remember before we had the rules for the raising products to a power. Now we're going to do or whatever it was. We got to realize that all this stuff. The reason why this is a rule is because it makes sense. If I have n a to the m's, then I have a to the mn, and you'll see why. What it just says is if you're raising a power to a power, right? If you're raising a power to a power, you find the product of those powers. For instance, 2 squared to the third, you can multiply now and get 2 to the sixth. Why? Well, because this 3 is attached to this parenthesis. So what it's saying is, I'm going to have 3 of these times itself. Right? And what are these things? They're 2 squared. Which is 2 times 2 times 2 times 2 times 2 times 2. Of course it's 2 to the 6th power. There's 1, 2, 3, 4, 5, 6 of them. Right? See, 2x to the 4. 4 what? 4 of these guys. I want 2x squared times 2x squared times 2x squared times 2x squared. So I end up with what? Remember, this is 2 to the first power. I end up with 2 times 2 times 2 times 2. X, 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 X. Alright, remember, 2 times 4 gives me that 8. 1 times 4 gives me that, this is 2 to the 4th. So x cubed to the 4th power. Why is this like this? Why? We know because this is 4 of these. It's x cubed times x cubed times x cubed times x cubed. It's 4 of these things, which is x, 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 x. So guys, if I write it all the way out, you know what it is. There's 12 of them. X to the 12. So here, woo, doggy, let's work all the way inside. I have 3 of these. So inside here, I have m squared times m squared times m squared, right? Which is mm. So this right here, in here, is m to the 6th. Now I want to square that. What does that mean? It means m to the 6th times m to the 6th, which is m to the 12th. Very nice. Notice if I just did 2 times 3 is 6 times 2, I'd get that 12. Interesting. And look at this one, m to the 3 to the x. Now here I can't show you, which is why there's rules, and it's nice. I don't know, I can't write out x of them. But if there were x of them, for instance, m cubed times m cubed times m cubed, and I went like this, x of them, you'd have x of these 3m, so of course you'd end up multiplying. You'd have m to the 3x. Okay? So you multiply the exponents and you're raising a power to a power. So what about the power of a product? Well, let's see. xy to the third. This is telling us here, ab to the m is the same thing as a to the m, b to the m. Or a to the m, b to the m is the same thing as ab to the m. Watch. xy cubed is the same thing as x cubed y cubed. Why? Well, what is xy cubed? It's 3 is attached to the parentheses. This is x times y inside the parentheses times x times y times x times y. Which, commutative, I can write it as x times x times x times y times y times y. So I have 3 of those x's and 3 of those y's. Squared, I want 2 of what's in here. I want 2 squared and x squared. This is a 1 and that's a 1. 2 to the 1, right? Which is 4x squared. Why? Because it's 2x times 2x. I'm going to reverse this. If I can say ab to the m is a to the m, b to the m, can I reverse it and go back? Yeah, I can rewrite this like this. xy to the 4th. Why? Remember, this is x, 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 x. Y, 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 y. I can rewrite this in any order, so I'm going to write it like this. And notice, what do I have? 4 little groups of this xy, so I can write it like that. Now I have 3 of these things. This is 5 to the 1, right? What am I going to do? What am I going to do? Oh, well, this is from the last section. I shouldn't even have put this here. I should have made this 5, well, whatever. I have this product to the third, so I'm raising each one to the third. So I end up having 5 to the third and z squared to the third. So I guess it is still here, right? And what does that mean? I get 5 to the third times z squared to the third, which is z to the 6th. So which is 125 z6. Or I could write this as 5z squared times 5z squared times 5z squared is 125z6. Alright, so there's a reason why they're like this. This isn't, someone didn't make up this rule and say, schneck to it. I mean, that's just, it's what an exponent means. It means repeated multiplication, so you can see how this rule comes about. Knowing the rule is nice for a quick and efficient way to get through these things and manipulate equations and expressions. Alright, we're going to keep going. Got a little bit of time left. Let's simplify these using rules of exponents, right? So let's see. I know what this is. This is -2. I can, since these guys are a product, I can write this as -2 to the 5th times k to the 5th. Well, 2 times 2 is 4. 4 is 16. So this is 32. And since it's 5 negatives, 1, 2, 3, 4, 5, these become there's going to be one left over. So I get -32. Is that what I said? K to the 5th. Now I could rewrite it like this. That was using the power of exponents. I could write -2k times -2k times -2k 5 times, and you see I have my 5k's and my 5 -2's. To this guy, let's use the powers. Let's use the power, what we know about raising powers, the powers of powers. I'm going to raise everything in here to the 3rd power, so I'm going to have this -3 to the 3rd power times x squared to the 3rd power times y 5 to the 3rd power. When I'm raising, this is 3 to the 3rd, which is -27, right? X squared, what happens when I'm raising this guy to a power? Remember, it's x squared times x squared times x squared. It is x to the 6. I multiply. And what do I have here? Y to the 5th. I have 3 of them. Y to the 5th times y to the 5th times y to the 5th, right? So I have 5, 5, 5. I have 15 y's all multiplied by each other. Y to the 15th. Okay? See how tricky that can be? Tough stuff, right? Or you could see, just do this cube, then I go 3 times 2 gives me the 6, 3 times 5 gives me the 15. But it's important to think of what's going on here, right? So let's do it. Ready? So I get 5 cubed is 125. A squared cubed, B cubed, right? Well, this is 125, A6, B3, right? Oh, I didn't do this part. 5A squared squared. So this is, inside here is 5 squared, this 2 squared, this squared, and this squared. 5 squared, A squared, squared, which is 25, A4, which is 125 times 25. I'm not going to do this out because it's not what we're worried about. A to the 6 times A to the 4th. I have 6 of them here times 4 more. I have A10, B cubed. Right? Very nice. Or I could have done, I know there's 3 of these, 5 times. I could have worked this out 3 times and this twice. Would have got the same answer. Now I have 3 of these. Remember, I'm raising both of them. I'm raising 2 to the 3rd power. I'm also raising x to the n to the 3rd power. Here I'm raising x to the n to the 5th power. Right? 2 cubed I know is 8. Now if I'm raising a power, what do I find? What do? I have 3 of these. It's x times n. So I'll do the multiplication. I'll show you why after. This is x to the 3n times x to the 5n. Now they both have the same base. I can add 3n and 5n. I get 8x to the 8n. Now this little part right here is the same thing as similar to this. Let's show you why it's to the 3n. X to the n cubed is just x to the n times x to the n times x to the n. So I have n x's, I have n more and n more. So how many groups of n? I have 3 groups of n, right? So I have 3n of them. Alright? Alright. So let's see, we have enough time to do the last one. We have 1 minute, so let's do this quickly. Ready? I multiply these, I get tmn. I'm going to do times 3, and again, tmn, right? So tmn times tmn, I can add those. So I get 3t to the 2mn. Here I get 2rxmr, 3 squared x 2y. And then I can add mr plus 2y. I get 2r times 9. And x mr plus 2y, I get x to the mr plus 2y. Do I have enough time here? Let's see. 42. Let's see. x2n, x3n, x, add them all. 2n and 3n is 5n plus 1x. All right. Thank you very much. Have a nice day.